October, November 2018, 970241, right? And question number 6. The topic is electric field. Define electric potential at a point. Work done in bringing a unit positive charge from infinity to a point within an electric field. Or you can say directly say the work done per unit charge. Work done per unit charge, right? So it is also same. You can write as well. Work done per unit charge. State the relationship between the electric potential and electric field strength at a point. So electric field and an electric field strength both are same in magnitude, but they are opposite in direction, right? So electric field strength and electric potential both are same in magnitude but opposite in direction, right? Two parallel plates A and B are situated at a distance of 1.2 centimeter apart in a vacuum shows in this figure. So here is X, there should be X, we need to find out the position between the distance between this and this plate. And the total displacement is 1.2 centimeter. Plate A is Earth and plate B is at the potential. So if we see the direction of electric field lines from bottom to up, right? So it is a higher potential 0 and minus 75 will be a lower potential. A helium nucleus is situated between the plate at a distance x from the plate. Initially, the helium nucleus is at rest on a plate where x is equal to 0. So you need to understand it. The helium at x is equal to 0 initially is at rest, right? So it has no speed. The helium nucleus is free to move between plates. By considering the energy changes of helium nucleus, explain why the speed at which it reaches plate B is independent of the separation of the plate. So, whatever will be the separation, it doesn't consider as far as the velocity is there. So, you know, the energy is equal to V over Q. So, electric field is equal to the potential difference times charge. And also, the kinetic energy. Kinetic energy is half mv square half mv square they right. So the kinetic energy is half mv square. So this is the potential and this is the velocity. There is no other force involved here, so the gravity isn't included. So half mv square is equal to vq, right? So v equals to vq over m, the root of that. So the expression is the speed is not dependent of separation, only dependent on the potential difference, amount of charge, and mass, right? According to this expression. So if you, instead of it, you can simply write v square equals to vq over m. This expression is independent of separation, which is x, right? Next. So next, as a helium nucleus moves from the plate A towards plate B, its distance x from the plate A increases. Calculate the speed of the nucleus after it has moved a distance x 0.4 centimeter from plate A, right? So if you see from this, right, minus 7.5 plus minus is the separation is, let's say, z1, and this point, let's say, is x, right, which is 4 centimeter. So potential difference, right, the electric potential will be the same. So E equals v1 over d. That's we have the formula of electric field, right, is V over D. So the V1 over D1, we use the ratio method. V1 over D1 is equal to V2 over D2, right? So minus 75, right, over 1.2 is V2 minus 1.4. So the V2 value will be minus 25 volt, right? So now the formula of speed we already use is V square equals to Q V over M, right? So after substitution is equal to times 2 into 1.6 into power 9 because the charge of helium, right, is 2 proton. So 1.6 into 10 to the power minus 19 is the charge of 1 proton times 2, right? So and the volt is 25 over, and it is m, which is 4u. So 4 and 1u is equal to 1.66 into 10 minus 27. So we will get 4.9 into 10 power 4 meter per second.